So what's up guys, it's your boy Mathew Javier again, and for the today's video we're going to tackle chapter 4 tutorial. And before I start, I hope you learned from something from this video, and let's go. So first, physical layer protocols. So physical layer protocols, there are first I will tell you there are types of connections. So as you can see, there are a picture that it have a home router. It have embedded wireless antenna. There are four switch or Ethernet switch, and for the one is internet connection. So we say that whether connecting to a local printer in the home or a web server in another country. Before any network communications can occur, a physical connection to a local network must be established. A physical connection can be wired connections using cable or a wireless connection using radio waves. So there are types of physical connection used as an independent upon the setup of a network. So I give you guys an example. So the example guys is, in many corporate offices, employees have desktop or laptop computers. So they are physically connected to via cable to shared switch. The type of setup is a wired network. Data is transmitted through a physical cable. So, in addition, wired connection, many businesses also offer wireless connection for laptops, tablets, smartphones with wireless devices. Data is transmitted using radio waves. The use of wireless connectivity is common as individuals and businesses alike. So that is for types of connections. So next one is the network interface card, or what we call the acronym of NIC. So network interface card, it connects the device to a network. Ethernet NICs are used for wired connections devices, whereas WLAN or wireless local area network and network interface card are used for wireless, and end user device may include one or both types of NICs. A network printer, for example, may only have an Ethernet NIC and therefore must connect to the network using an Ethernet cable. Other devices such as tablets and smartphone might only contain a WLAN NIC and must use a wireless connection. So note guys that not all physical connection have an equal in terms of performance level when connecting to a network. So there are the purpose of physical layer. So the purpose of a physical layer is that the OSI physical layer provides the means to transport the bits that make up a data link layer frame across the network. This layer accepts a complete frame from the data link layer and encodes it is a series of signals that are transmitted onto the local media. The encoded bits that comprise a frame are received by either in the end device or the intermediate device. So it composed of encapsulation and decapsulation, also segments, packet, frame, bits, and signals. So that's the physical layer. So physical layer media and the physical standards. So physical standards. So from what I've known, uh, physical layer standards are implemented in the hardware and are governed by many organizations. It also governed by the ISO, EIA or TIA, ITU-T, and ANSE, and the IEEE. So, but it means that ISO is the Inter-Organization for Standardization. The TIA is the Telecommunication Industry Association or Electronic Industries Association. The ITU is International Telecommunication Union. Third one is the American National Standards Institute or ANSI, or the IEEE, the Institute of Electrical and Electronics Engineers. Last one but not the least is the National Telecommunication Regulatory Authorities, including the Federal Communication Commission or FCC in the USA and the European Telecommunication Standard or ETSI. So those are the physical layer standard implemented with the governed many organization that this what I say the company organization that includes of it. So the next one we're going to do or the next one is the network media. So guys, network media is composed of copper cabling, uh, copper cabling. So copper media is unshielded twisted pair of UTP and shielded twisted pair of STP and coaxial cable. There are so many types of cable that are which is there are those what I'm saying, the UTP, STP, and coaxial are the three main types of copper media used in networking. So the next one is what is an unshielded twisted pair cable. So untwisted shield pair cable, it have a color-coded plastic simulation, electrically isolates wire from each other and identify each pair. So it twisted also. The projects the signal from interference and the outer jacket protects the copper wire from physical damage. So that is the unshielded twisted pair. It's common use in the networking media. UTP cabling terminated with also an RJ45 connection is used in reconnecting networks with intermediate networking devices and switches as routers. So the next one is the copper coaxial cable. Coaxial cable. It is a copper. First, the inner is a copper conductor. The next one is the plastic insulation. Third one for the braided copper shielding, and the outer part is the outer jacket. So there are also type of coaxial cable, the B and C, the N type and the F type. So guys, coaxial cable is a coax for short, gets its name from the fact that there are two conductors that share the same axis as and a copper conductor used to transmit the electronic signals, a layer that flexible plastic insulation surrounding a copper conductor, and the entire cable is covered with a plastic jacket to prevent minor physical damage. So it have wireless installation, cable internet installations, so on and so forth. We have UTP cabling. We have also the properties of UTP cabling, UTP standards, UTP connectors, and types of UTP cable, testing UTP cables, and cable pinouts, which we have in chapter 4, we have an activity that you have mass, or you are going to what we call you are going to put the colors of align the wire colors to build the TIA, and carryable pin out to drag colors to the each wire to correct placement on the RJ45. So next one we are going to is data link protocols. So data link protocols or data link layer. Data link layer. Data is the layer of the OSI model or layer 2 is shown in the who is responsible from it. So first we have the physical, the second is data link. So allowing the upper layer to access media and also accepting layer 3 packets and packaging them into frames, preparing network data from the physical layer, controlling data of place received on the media, and exchanging frames between nodes are of or over a physical network such as UTP, optic, and receiving and directing packets to the upper layer protocol and performing error detection. So that is a data link layer. So there are also data link sublayers, media access control, providing a access to media, and data link layer standards. So data link layer standard, guys, is you unlike the protocols that of the upper layer TCP and IP suite, data link layer protocols are generally not defined by requests for comments RFCs, although the Internet Engineering Task Force maintains the functional protocols and the service of the TCP IP protocol suite in the upper layers. The IETF does not define the functions and operation of the model network access layers. So engineering organization that define the standards and protocols that are applied to the network access layer. That is include the IEEE, the ITU, ISO, and ANSI. So the next one is the media access and control. So media access and control, we have the topologies. Topologies, the controlling access to the media, and physical and logical topologies. So we have also WAN topologies and LAN topologies. So when we say common physical WAN topologies, it have to be point to point, hub and spoke, and mesh. So point-to-point topologies is simply a topology that consists a permanent link between two endpoints for a reason. This is a very popular WAN topology. The hub and space, a one version of star topology. The star topology is one at the middle and 5 to the outer port. So interconnects branch shoots using point-to-point links. The mesh. This topology provides high availability, but it requires every system to be interconnected to every other system. Therefore, the administrative and physical costs can be significant. Each link is essentially a point-to-point link to the other node. So that is the WAN topology, so wide area network topologies. So the LAN topologies. Local area network topologies is using also the star, the extended star, the bus, and the ring. So bus topologies, star topologies, as I said earlier in the one topology is the same but more crucial and what we say hard way in the LAN topologies. There are also half and full duplex. There are also media access control methods, contention-based access, and contention-based access, or CSMA-CA. So there is also the data link frame, which is the frame fields, and the layer 2 addresses and LAN and WAN frames. So that is all from media access control. So that is all guys, and thank you for watching for this chapter 4 tutorial. I hope you learned something from this video, and that is all, and thank you.